LibGDX. It was created by Mario Zechner, a Java library that would simplify game and effects development on Android. He originally called it AFX, Android Special Effects. Now, as he was using it, he felt that by providing a development environment on desktop, which was not tied to Android Development Studio, would provide a major boost to usability of his library. So then what he did, he added support for desktop applications. Basically, you could build an abstract game that would use some abstract APIs, and you could build it on the desktop and it would run in a window. Now, once you finished with the development, and remember on desktop, we have a variety of graphics editor, sound editor, music, you name it. And it's very easy to run, it's very easy to test. And once you've done developing your game, you could just build it for Android and you would get Android application straight away from the same code base. And he was quite successful. And quickly a community grew around it that designed support for iOS, and they also provided support for HTML5, where this Java code was compiled into a version of JavaScript using Google Web Toolkit. So it's cross-platform, and although LibGDX provide quite generic APIs, it had to provide a fairly platform-specific implementations for different platforms that it supports. And if you've ever tried to program for HTML5, you know that it has some limitations. For example, in JavaScript, we don't have multi-threading. And without multi-threading, we cannot do a lot of nice things that we can do using multi-threading, like programming two algorithms running in parallel and synchronizing it via pipes, messages, or by some other means. So in desktop, we have the main method that starts the main algorithm. In Android, we have multiple functions, which are called at different stages of the life cycle. And I think LibGDX did a nice job of kind of creating an average of these different approaches that can run on all of these platforms. However, for each platform, they had different backend. Minecraft is the main, well, the interesting thing about Minecraft is that it's built directly on top of this LWJGL, lightweight Java game library. And it's by far the most popular application of it. So in LibGDX, they needed a backend for the desktop, and that's what they used. On Android, instead of this LWJGL, they use functionality provided by the Android software development kit, and they use cross compilers for HTML5 and iOS. What is exactly this LWJGL, which is the backend for desktop games written with LibGDX? It is basically a fairly thin wrapper of OpenGL functions. OpenGL stands for Open Graphics Library. It's an open standard maintained by the Kronos group. It's a historic standard. It was created back in the 90s by Silicon Graphics, which, as you may have heard, was one of the pioneers in graphics workstation development. They designed their own hardware that had these graphics accelerators, which nowadays we have in our PCs. OpenGL was one of the standards proposed at the time. Now, what is interesting and nice about OpenGL that you potentially do not need a hardware accelerator to run programs written for this API. All of its functions can be simulated in software, but because it's designed to utilize hardware, it has some peculiarities. So you have this notion of shaders, you have this notion of textures and 3D geometry that you send to this hardware acceleration subsystem. Have you ever tried to create 3D models? Well, if you did, you know that in 3D modeling, we have two categories of things. We have 3D shape and we have two-dimensional textures, which we chop and kind of paint or glue on top of the three-dimensional shape. And that's how 3D modeling is generally done. And what LibGDX does, it uses this three-dimensional machinery to play two-dimensional games. And that's what they do. So basically, they have a single plane in three-dimensional space, not a complex 3D shape, but just a plane. And on this plane, they put some quite simple textures. The plane is called the world, and it lives in three-dimensional space. And there is a camera that looks straight onto this plane. And because of this, it's similar to orthographic projection. Do you know what orthographic projection is? When we have a three-dimensional shape, we can create an orthographic drawing with three views: from top, from side, and from the front. So when we have this orthographic camera, it's basically looking straight at the plane, and we see it undistorted, as is. That's the idea. So we have the world, a plane in 3D space. We have a camera that looks directly onto it, and the information received from the camera is then somehow presented to the user through an abstraction called viewport. Viewport could be a mobile phone screen. It could be a window on the desktop platform or something else entirely. Now, it's useful to explore an application, a demo application that you can create with the demo project, and we'll do it in a moment. But before we do this, I want to explain a little bit about class structure of this application. One part is platform specific, and it's called application. That's basically your LWJGL window and the process behind it that runs your game. On desktop, it's LWJGL program. On Android, it's Android application. On HTML5, it's basically a frame in your HTML window. But either way, it would be a subclass, or not a subclass, an implementation of the application interface. Now, this application interface has an instance of application listener interface, which is basically your platform independent game. And it has a number of functions that must be implemented. One is called create, which is called when you start your game. Another is called dispose, which is called at the very end of the program lifecycle when you terminate the application. It has pause and resume. That's when you swipe your game out of the screen and when you swipe it back. You have resize when you change the dimensions of the window. And crucially, you have a method called render, which is called multiple times per second, that actually draws the picture or that the user observes. So application and application listener, they're just Java interfaces. So to build a game, you need to create instances of both. And one of them, LWJGL application, we already get with the library. And my game, you create and modify and edit. Now, to make life easier, LibGDX contains a number of so-called adapters, which are classes that provide some very simple default behavior for these standard methods so that you don't have to write them every time. So what you do, you subclass either application adapter or game class in your project, and only modify certain methods in your own classes, and it inherits default behavior from these adapter classes. So libgdl provides two adapters. One is called application adapter, which has all these methods realized somehow, and it has game adapter. Now, game adapter is different from application adapter in that it provides this notion of screens. In a game, you have multiple screens. You have start screen, you have play screen, you maybe have score screen, and so on. In a game, we have additional method called set screen, which takes screen as a parameter, and screen have much the same methods as a normal game. So it has render method, it has resize, pause, resume, dispose, but it also has additional show and hide methods. And the idea is that your main game program can use this set screen to switch from one screen to another. And to switch between screens, you just call set screen with the screen object that you want to be visible to the user. And all calls to render in the game are then redirected to the render method of the screen that's currently selected. So the idea is that you instantiate all the necessary objects, textures, sounds, fonts, whatever else in the create. Then you define several screen objects that provide different render methods depending on what they display to the user. And then you provide some logic that allows you to switch from one screen to another. Okay, so let me briefly walk you through the standard project that you can build with the libgdx installer, and it'll create a folder with the game. And when you go into this folder, you can run the application using this command, desktop run, and that's what you're going to see as a result. So that's hello world libgdx style. And if you look at the project structure, it will look like this. So you have two sub-projects. One is called desktop and one is called core. If you create support for Android, iOS, and HTML, you'll have additional sub-project for Android, iOS, and HTML. But at the minimum, you have a desktop and you have core. So core is platform independent, desktop is platform specific. And if you look inside desktop, there is basically a very simple program that does a very simple thing. It creates a configuration object that contains settings such as dimensions of the window and some additional specification which are specific to LWJGL way of displaying information on the screen. And then you can modify these settings here. So you could say config, and it provides you a number of methods to manipulate this. And then after this, you call this, you create an instance of LWJGL application. You give it the configuration as the second parameter. And as the first parameter, you create an instance of the game object. And it goes inside and never returns. The MyGDX game object is platform independent, and you can run it on different platforms in pretty much the same way, only you'll have different application instantiated depending on the platform. And the application itself is defined in the core, and in this case, it's quite straightforward. So as you can see, MyGDX game extends this application adapter. It provides only three methods: create, render, and dispose. Sprite batch is basically a way to render textures on the world plane. and you need it, and you use its methods to kind of paste instances of texture on the world plane. Now, second line here, well, img variable holds an instance of the object texture, which is basically a JPEG file. Now, render is fairly simple, and it's representative of pretty much all render methods. So first, you start off by clearing out the world plane. You clear it, and you specify the color you want to clear it with. So your color specification contains 4 elements: intensity of red from 0 to 1, green, blue, red, green, blue, and alpha that specifies opacity, or transparency, if you like, of this color. 1 means opaque, and 0 means fully transparent. And then we draw, so we typically call begin methods on the batch object. Then we draw multiple instances of different image objects on the world plane. And finally, we call end, which actually transfers all of these images to the graphics hardware and get them depicted on the world plane. So the thing is that once the application is started, it calls create once, and then it repeatedly calls this render method. And if you want to design any animations, we just need to devise a way to slowly move different images that we display on the world plane as the time passes. And LibGDX conveniently provides us additional variables that describe the passage of time, which we can use to implement motion with the required speed and other properties, until eventually we close the window. And at that point, importantly, sprite batch and the texture object has to be destroyed explicitly. So even though Java provides automatic destruction of objects, in LibGDX, we actually have to explicitly dispose of these objects. And that's it. So I'll leave you at that, and we will continue speaking about handling input and multiple screens. Thank you very much.